All right. So for a function to have an inverse, right? For a function to have an inverse, it must, right? For a function to have an inverse, it must be what? Right? For a function to have an inverse, right? It must be bijective, right? What does bijective mean again? Right? It means that it's both one-to-one or injective. It's both injective and surjective. Okay? So you have to show that it's both of them before you can find the inverse, right? What's the geometric relationships between the inverse and f of x? Anybody remember that? What's the geometric relationship? Opposite, narrow like that. Next side, do like that. Something to do with y equal to x. Anyway, you're introducing maths. Right. So if I give you a function and the function is f of x, then its inverse is the reflection in the line y equal to x. Okay? So f inverse x is the reflection of f of x in the line y equal to x. Okay, so that's something for you to remember about f inverse x, right? And then we'll take a look at the steps in finding the inverse. Remember, after this class, we're following the timetable, right? Any holidays. So this is the last class until when school closes, following the timetable, any holidays. All right. Anybody remember this? What is f of f inverse x? Or what is f inverse of f of x? But what's the general answer? Huh? Somebody say it now. What is it? Shavish? Am I here? Oh, you say something. I think it was right. Come, there's one chance to get something right. All right. Anybody online remember? What is f inverse x or f inverse f of x? If you find the inverse of f of x, what will you always get? So think about this, right? Think about this. We'll come back and write up, right? Right? Suppose I gave you this relationship here. Suppose I gave you the relationship between x and f of x. Right? Let's call that y actually. Let's call this y, right? And to go from here to here, we need a function f of x. Then what is the mapping from here to here? How do I map all the y values to all the x values? How is map all the y values to all the x values? F inverse x, right? Correct? All right. Are you okay with that? So to map all the y values back to the x values is f inverse x. All right. So what about, in fact, let me give you the word in here. This is your domain. This is your range, right? Let's do codomain actually. What is the domain of the f inverse x? What's the domain of f inverse x? What's the domain? F. Right, so the domain of f inverse x is the codomain of f of x, right? I'm making sense? The y values. So the x values of f inverse is the y values. All right? So the domain of f inverse x is the codomain of f of x. Right? And the codomain of f inverse x is the domain of f of x. All right? Just make a note of that, and I want to build up into answering what we talked about a little while ago. A recording, yes, a recording. So I kind of building up into what I was asking a little while ago, right? All right. So, oh, you're right. So, all right, ready? So take a look at the red part underneath, right? Let's pretend I gave you a function, f of x is x plus 1, right? And I wanted to get the image of 2. What's the image of 2? 3. Right? So that'll be 2 plus 1, which is 3. That's okay? But suppose to go to the next relation now, I needed to get f inverse x. F inverse x is what? You can do that mentally in your head. If f of x is x plus 1, what's the inverse of that? What's the formula for the inverse? What? Wait, no. Formula before you reach there. X minus 1, right? That's okay? Right. Nice. So, what will 3 be mapped to? 3 will be mapped back to 2. You're saying that? Suppose I had 4. 4 will be mapped to what? 5 will be mapped to what? Are you okay with that? Yeah? So let's go generally. X is mapped to what? X plus 1, right? So x plus 1 is mapped to what? You sure? X. That's okay? X plus 1 minus 1 given impact x. So what you'll notice? What is f inverse of f of x? So every time you find f inverse of f of x, you're getting back what? They get back x. They get back x, what you originally had, right? So if I say, here's what? You have f of 2 was the inverse of f of 2. You will always get back 2. Follow with me there? Yeah? Suppose I go the other way around. Suppose I gave you f inverse and I want to go here and then here. It'll be the same thing. Okay? So it means that f of f inverse x is also x. Are you okay with that? So we did 2 things there. We discovered this relationship and we also introduced composite functions. A function of a function. So if I ask you to draw the relation diagram for a composite function, it looks like that. Okay? By the way, to have this part here, so I'm taking that off, right? So basically, you could go back to the first part of your notes. I'll come back here just now and write x on the end. Write x here. Okay? F of f inverse x is equal to f inverse f of x, which is equal to x. Right? Just go back to the first part of your notes. All right? Copy down the example in red to explain where it came from, right? That's it. Killing. That's good. I'll get it sorted out by. Okay, so that's a rule for us to remember whenever you see this, right? If you have to find the inverse of f of x is x, if you have to find the other way around, it's also the same, right? So once you see it, you don't have to go and work it out. You know, you'll always get back to your original value, right? Right, how do we find the inverse again? Anybody remember the steps? Right, first thing is what? Let y equal to, and then interchange x and y, and then solve for y. All right. So basically, what you're doing is you originally had y equal to x. You're trying to get an equation x equal to y, and that'll be the inverse relationship. All right. So those are your 4 steps. Let's just do a in between. I'm giving you a medium here, right? Try this, please. Same thing for maths. Find the inverse there. 3x minus 1 and 2. Two. Pure maths is 1, 2, 3. That's physics. Module 3 is the trickiest, so we'll see that for last. Take your time and do it. During the holidays, we'll finish up module 1, and we will reach throughout trigs and probably coordinate geometry. And not hard, just take your time and do it. It's not bad. Huh? Everything normal. It'll be mixed, right? To both of them. Hopefully, I'll have it board. Finish. Right? So you should let y equal to f of x. So y is equal to 3x minus 1 over 2. Then we're going to interchange x and y. So x is equal to 2y minus 1 on 2. Oh, sorry. 3y minus 1 over 2. And then we're going to solve for y. I'll squeeze it in right here. Cross multiply one time, you'll get 3y minus 1 is 2x. 3y is 2x plus 1. Or y is equal to 2x plus 1 divided by 3. Okay? So that is your inverse. 2x plus 1 over 3. And remember, graphically, the inverse is a reflection in the line y equal to x. How you obtain now? Remember that? If I give you a function and you have to reflect it in the line y equal to x, what is change? So suppose I give you something like this. What's a reflection of minus 3, 5? 5 minus 3, right? Right? Switch the x and the y. So it will be like 5 minus 3. Okay? Well, a little closer, of course. Let's remember that, right? So reflecting the line y equal to x, switch the x and y values. Okay? Okay, so that's the theory behind it. We'll do some past papers just now on this. Right? Before we do that, let me just run over what's a composite function. Spell that right? Feeling wrong. Right? Or I just feel wrong. Right? So composite functions, right? Right? So these are functions. Right? These are functions that consist of two or more functions, right? That consist of two or more. Right? For now, we'll be just doing two functions. Right? So for example, if I give you this f of g of x, that's a composite function. Right? What does this mean in words? What does f of g of x mean? Which one and which one? Which function goes into which function? Right. So this is saying that g of x into f of x. Similarly here, f of x into g of x. What about f squared? What does that mean? What does f squared x mean? So f squared means f of x. Ready? Let's start one. This is 2014, number 2A. Let's now share it. Huh? All right, what you see here? All right, let's start here. This is June 2014, number 2A, right? right? So they gave you two functions, f of x and g of x. They want you to find f squared. They want you to find f squared and f of g of x. And then let's see if we can figure out the relationship. Huh? Sorry? Yeah, that's in part 1 and 2. Part 1 is the only calculation. I'll start with this now. Right? F squared means what again? F of x, right? So f going back into there. And then the g going into there, and something should happen. And hope what y'all get for part 2. Okay, so let's work it out. Let's see how it went, right? How far you should reach? So part 1, they want you to find f of x. So f of, open brackets, are replacing f of x with 2x squared plus 1. And then I'm going to put 2x squared plus 1 right in there. So I'll have 2 open brackets, 2x squared plus 1 all squared plus 1. All right? When you square it out, you will get 4x to the 4th plus 4x squared plus 1 plus 1. So you'll get 8x to the 4th plus 8x squared plus 3. Anybody get that? Yeah, all the way there? Nice. So that's it, f squared, right? And part B, you want it f of g of x. So f of g of x is the square root of x minus 1 and 2. So you're going to put the square root of x minus 1 on 2, same thing, right in there. Remember, g going into f, okay? So it will be 2 by the square root of x minus 1 on 2 squared plus 1. That's okay? So you're going to square the square roots. That'll cancel off. And then 2 by 2 is, that'll cancel as well. And you'll get x minus 1 plus 1 is x. What does that mean? It means that g of x must be the inverse. All okay with that? Amelia, all okay there? Emily? Any questions online? All right, next one. And everybody writing, should we check your writing, sir? Next one is 2013, number 2, A and B. Anybody writing online? Let's go again. First part, you have to show it 1 to 1. Second part, you have to find those two. Huh? X squared minus x? No, I think so. I mean, if I show it. Oh. Line or the formula? f of A equal to f of B, then A equal to B. Try this there. There's one function I didn't talk to you about. Anybody remember it? Modulus, right? So I want to show you. Did I show you how to sketch it? When we did transformations? Check and see the last transformation. Or I said I'll just wait. I'll wait. Okay. All right. Yeah, that's one. Anyone you want. Look at the domain. X is more than or equal to 1. Okay? Remember that. Timothy, do you even log in online? Because. Who? Rajuna there. Are you there? Kaylin, Brianna, right? Brianna. Janessa, Adrian, Brianna. Azaria. You see Azaria? See, I come in. Amelia, you who's coming to Azaria. Holes here? I put some holes this morning. Earlier. But I holes hiding there. Right holes, you ready? But if you want to sketch it, because it's a quadratic and easy. If you want to sketch it, it's up to you. I will use the algebraic method. Okay? F of A equals to F of B and so. Actually, I find it sketch easy. I'm going to do a sketch. Huh? Yeah, well, I had to complete this square, right? And we had to complete this square. But this one here, right? Before I even do it. Right? Before you try to use f of A equal to f of B, then we have to show A equal to B if it's 1 to 1, right? Yeah, if they don't state what method to use, you can use anything you want, right? So because the mathematical was tricky, I find the graph would have been easy, right? But mathematically, here's what you have to do. You have to take this and complete the square. So it's in the form A by X plus 8 squared plus K. You want to complete the square because what you see, you'll end up with A squared minus A is B squared minus B. What are you going to do? But it have numbers there. Oh Lord. Yeah. Okay, well I'll go and do it, right? A is how much here? A is 1. The value in front of x squared. And B is -1 and C is 0. Okay? H is B on 2A. So that'll be -1 and 2. So B is -1/2. And K is C minus A squared. C is 0, A is 1, and H is -1/2 squared. So I got -1/4. So f of x is really 1 by x -1/2 squared -1/4. Because that's the only way to simplify the part I was showing you earlier. So now we could find f of a. F of a is a -1/2 squared -1/4. And f of b is b -1/2 squared -1/4. Now we could use it, right? And see what will happen. Hurry up. So every time you have a quadratic and you want to use this method, you have to complete the square. Sorry? You didn't do that math? Yeah, but I should have when it comes to the square maths. Yes, that's a regular thing. Yeah, that one. 4ac minus b squared on 4a. 4ac minus b squared on 4a. So, what will happen to the quarters? Trouble? Rihanna? Trouble? Oh, if 1 to 1. That's the rule from last week. I got to pay attention in my turn. You was online last week? You would pay attention online. Right, so the quarters will cancel and you'll get a -1/2 squared is equal to b -1/2 squared. And then you'll, square both sides. So you'll get a -1/2, b -1/2, and then the half will cancel. So you'll get a equal to b. Yeah? Somebody else, right? You want check it? Okay, let's move. I'll go downstairs. Right? But just one thing I want to remember. whenever you have the square root of something, remember it's plus and minus, huh? So it's plus and minus b -1/2. Right? Plus and minus b -1/2. That's okay? So really and truly, there's something I kind of left out here. But let me show you why I left it out, right? When you work this out again, a -1/2 is plus and minus b -1/2. So plus and minus means you're doing it twice. A -1/2 is equal to b minus a half. That's when it's plus, and a equal to b. But when it's minus, you're going to get a minus a half is equal to minus b minus b by a half. But based on the rules here, based on the domain given, can the values be negative? Can the value be negative? So you could say that this here does not exist. Because of the domain, all your values are more than one. All your values are more than one. So therefore, it implies that since all your values are more than one, it implies that that right-hand side does not exist. Remember, when you find a square, it's plus and minus. All right? All right? That's the mathematical way. The easier way for this question, the easier method for this would have been graphical. You'll follow why I ignored the negative? Yes. I ignored the negative because of the domain given. X values, they are not negative. Right? Let me take it off. That's not. Kill it right. I do next. Right? Graphically, f of x is equal to x squared minus x is a what? It's a quadratic, right? What are the x-intercepts? Solve x squared minus x equal to 0, and you'll get x by x minus 1. So you'll get x is 1 and x is 0. So the y-intercepts are 1 and, sorry, the x-intercepts are x is 1 and 0, and the y-intercept, there's no y-intercept, right? So that's 0. You'll see that? So this sketch will look something like this. But what did the question say? Question says that you only want a domain for x is more than 1. So you could ignore this part of the graph. Okay? So your graph will look like this here. And then you can do the horizontal line test. Draw a horizontal line, it'll only cut once. Therefore, it's 1 to 1. It don't matter, you can show it anywhere. Right? Once you have a sketch, show it anywhere and show that it cannot touch more than once. Okay? So once you remember how to sketch a quadratic, a sketch would have been much easier than the next method. Okay, finish the last part for me now, please. Finish G inverse, and that part there. See it? Yeah. We now copy that down. Huh? Sorry? What you say? So when you're doing loves, you didn't know it. Actually, I wouldn't show the modulus today. I'll do that next week. I want to do plenty of questions on it. After earlier. But a big now. I'll do that. You leave it out today, but like when you do it next dance, make sure you do it. Huh? They wanted to make sure you read it properly. Well, what shall got for f inverse x? X minus 2 and 3. And then g, in fact, let me just do g inverse. Y is equal to e to the 2x. So x is equal to e to the 2y. Then what you'll do? Take ln on both sides. Ln you'll cancel off. Ln e is 1. So you'll get ln x is 2y. Y is equal to ln x on 2. Okay, or you can write it like this. A half ln x. Or if you want to look real smart, you can write it like this. Ln square root of x. So remember that? Power rule. Yeah? Bring the half and put it on top here, right? All you have to do now is find f of g of x. take out that part. That's slow. Right? So f of g of x is what? F of, open brackets, e to the power of 2x. So you're going to put e to the 2x in f of x. So that'll be 3e to the 2x plus 2. All right? You get that? Vanessa? All right, one more. This one, I don't know if you could do it without graph paper, but I wanted to talk with you, right? And we're trying to do a sketch. We are trying to do a sketch. Huh? Nah, you don't need to grade here. In 2018, they started to ask questions looking like this, right? I'll share it in the group as well. I want you all to look at it. You could probably write on it with your phone, with your finger or something, right? Take a pick of it now. I'm gonna share it in the group. 2018, yeah, number 2. All right. So take a look at that question. I want you to tell me how we can find the inverse. Yes, catch the inverse and use a graphical method to show it by objective. I will try it. I'm gonna tell it this. I'm gonna take this off. Everybody have it? Scatter it to the pick up it now. Yeah, Chris, take it now. I sent in the groups I want you all to use the number 2. Take it now. And you want the screen? Right. So I want you to tell me now how to do that. You can have the screen, right? So you use your iPad or your phone. How are we going to get it inverse and how are we going to show it by objective? Think about it. We have to use the rule from last time. I seen something looking kind of wrong earlier. I'm pretend to sketch it. Anybody online could help? Okay, disconnect, right? So don't watch it anymore. You are disconnect, right? Anybody can help? How do you sketch the inverse if you have f of x? Where so? A reflection in the line y equals x. You have to draw the line y equals x first. Then try to reflect. Right? Reflecting the y axis. So let's sketch. So what is the reflection? It's a reflection in the line y equals x. So draw the line y equals x. And how you reflect? All the x and y coordinates change. Right? Pick a few. It was working on me. What? Well, I didn't check today, but it was working on the manual messenger. Not live right now. Right here, anybody remember online? So you're drawing the line y equal to x and you're going to reflect it, right? Oh, shucks, my pencil now working. So draw the line y equal to, it has to be exactly earlier. The line y equal to x will pass through 1, 1, 2, 2, 10, 10. Okay? So make sure you draw that line perfectly. And then pick up your coordinates and switch it. For example, I don't know how to show this, huh? And now. So back that, huh? Or he reset, take off. I think he reset the whole computer. Well, I use camera. It wasn't starting up at all with nothing on it. What's that? I'd move it here. I'd move it. That's the error. But I just see. The error, no, I just see. I just do it here and leave it. All right. Yeah, just pick new meter. Connect already? No. Don't worry. Yeah. Yeah. Get picture last time? Right, yeah. So when you're reflecting the line y equal to x. So if you reflect 2, 4, 6, 8, 10, right? If you reflect 2, 8, 2, 8 becomes 8, 2. So this point here, for those who online and could see face to face might not be able to see. No, all they can see. They can see online. Right, but I just giving you an idea, right? There's one of the plots, one of the points is 2, 8. So instead of 2, 8, you're going to plot 8, 2. So 8, 2 will be somewhere here. Right? Our next point would have been 0, 0. Our next point would have been 1, 1, 4. 1, 4 becomes 4, 1. Right? And you just smoothen it out. Right? It's not the best looking thing, but it looks something like that. Oh wait, no, you can see it, man. I'll see anything there? Just continue there. Continue. Yeah. Excellent. Well, it's not the smoothest. Right? So your reflection looks something like that. It's not the best. 548.43. Right? It's not the best looking thing there, but you all follow what I did? Right? I'll fix it a little better for you after. Right? How you're going to show that it's bijective? Horizontal line test, and you can do the vertical line as well. Because you're using f of x. So you're drawing a horizontal line and showing that the function 1-to-1. And you're drawing a vertical line as well and say, since it passed both the horizontal and vertical line tests, the function is both surjective and onto. Sorry, surjective and injective. Okay? Sketching is the most important thing. Once you can sketch, these questions become easy. Right? But you all see what you did, right, Nikolai? You reflect along the y-axis. You have to reflect along the line y equal to x, right? I'll do it neater for you and send it, right? Okay, so nice. That's it earlier. Already everything working good now. All right, online. So next day we will take a look at